Hi everyone. In this video, I wanted to do a couple more examples where we use the quadratic formula. And with these examples, I wanted to show how sometimes we don't always end up with real numbers. Sometimes we end up with a complex numbers as our solution. So let's go over just real quick what the quadratic formula is again. So we have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c. And we're going to take this whole thing over to a. And here, our a, b, and c are our uh, coefficients in our quadratic equation. Okay? And remember, it always has to be set equal to 0 as well. That is also extremely important here. Okay, so let's go ahead and get right into this one and see if we can solve it. The nice part about the quadratic equation is that we are able, a quadratic formula is that we are able to always find solutions. So here, even though we don't have any real solutions, we can still find complex solutions. So let's see what we get. So we have x is equal to negative 3 plus or minus the square root of b squared. So we have negative 3 squared minus 4 times 2 times 6. Okay? And this is all going to be over 2 times 2, 2 times a. Okay, let's try and simplify this. So negative 3, that's positive 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 2 times 6, so that's 48. Okay? And this is all, let me turn on my do not disturb here. This is all going to be over 2 times 2, which is 4. Okay, so now let's see what we can do here. So here we're going to have 3 plus or minus the square root of 9 minus 48, which is negative 39. And this is all going to be over 4. Okay, so what we'll notice here is that we have a square root of a negative number. Therefore, we're going to have a complex uh, answer here, okay? So we're just about as simplified as we're going to get it. I don't think we can do much with the square root of 39, but we can pull an I out, so to speak, of the square root of negative 39. So I have 3 plus or minus I times the square root of 39 over 4. And what we do usually remember, if we remember back to how we structure complex numbers, we have a real part and we have an imaginary part. So we can separate this into 3 over 4 plus or minus the square root of 39 over 4 times I. Okay? And you can leave it like that, or you can write it as x is equal to 3 over 4 plus the square root of 39 over 4 I, and then 3 over 4 minus the square root of 39 over 4 I. Okay? So this would be our answer here. So you will sometimes get these complex solutions like this, and that's not necessarily a bad thing if you do. Okay? Um, so what you'll notice is anytime what's on the inside here of the square inside of the square root here, this is if this is negative, then we know that we're going to have a complex solution. Okay, and this thing in here, by the way, you may see something on Alex about this. This is called the discriminant. Okay. So what you can do is, if you want to figure out if you're going to have complex solutions or real solutions, you can just take b squared minus 4ac and see if it's positive or negative. If it's positive, you're going to have real solutions. If it's negative, you're going to have complex solutions. Okay, so just a little fact with that. It can be very helpful with determining what types of solutions you're going to have. Just that little piece of information, b squared minus 4ac. Okay, let's do one more. Here we have 5x squared minus 4x plus 3 is equal to 0. Okay, so let's go ahead and do the quadratic formula. We have x is equal to negative, well, first let's label a, b, and c. So here we have a is equal to 5, b is equal to negative 4, and c is equal to 3. So we have negative b, so negative 4, plus or minus the square root of b squared, so negative 4 squared minus 4 times a, which is 5, times c, which is 3. Okay, and this whole thing is going to be over 2a, so 2 times 5. So we have negative 4 is positive 4, plus or minus the square root of negative 4 squared, which is 16, minus 4 times 5 times 3. So that would be minus 60. Okay, and this is all going to be over 10. Okay, so if we take this a little further, we're going to have 4 plus or minus the square root of negative 44. Okay, all over 10. Okay, and then what we can do here is we can go ahead and pull out the I, so to speak, right? So this will become 4 plus or minus the square root of 44i all over 10. Okay, and then what we can do now is we can actually split up the square root of 44 into the square root of 4 times the square root of 11, because 4 times 11 is 44. Okay, and this will all be over 10. So square root of 4 is 2, so we'll have 4 plus or minus 2 times the square root of 11 times I, all over 10. And what we'll notice is that all of these, the 4, the 2, and the 10, they're all divisible by 2. So we can factor out a 2 here. So that's going to give us 2 plus or minus the square root of 11i, all over 5. Okay? And so therefore, that's about as simple as we are going to make that, but we should split this up. So we'll have x is equal to 2 plus the square root, 2 over 5 plus the square root of 11 over 5i, and then x is equal to 2 over 5 minus the square root of 11 over 5i. And that will be your solution.